Good morning and welcome to Understanding and Applying Solar Energy for Domestic Needs. It's a long and puffy title, but really what it means is understanding how to use solar energy for your home, your car, your off-grid cabin, or something else. In our case, it was a boat. So while we wait for others to join, we're going to have a couple of slides to show you some basic video and information about renewable energy.
Energy consumption is a huge part of our daily lives. We eat with energy. We travel with energy. We work with energy. And we even flirt with energy. But where does all of this energy come from? Today we gather most of our energy from coal, oil and natural gas, also known as fossil fuels. Additionally, we gather energy from biomass, nuclear and renewables. Fossil fuels consist of extracted decomposed organisms and plants that existed millions of years ago. Biomass converts plants into biometric material to produce energy. Nuclear energy is released during nuclear fusion. Lastly, renewable energy comes from a source that's not depleted when used, such as wind or solar power. But what's the profound difference between them? How they affect our planet? Fossil fuels cost more than what we pay at the pump and impacts our environment in many ways. These impacts include global warming, air quality deterioration, oil spills, and acid rain. It's also projected that fossil fuel resources will be depleted within the next 50 to 100 years. Biomass and nuclear energy also have similar issues. We need a solution relatively fast, and luckily, we have one. Renewable energy comes from resources which naturally replenish in our lifetime, whereas fossil fuels are a one-time use resource in the human timescale. Resources for renewable energy include sunlight, wind, rain, tides, waves, and geothermal heat. The best part is that we don't need to compromise our planet to harness it, nor do we have to rely on other nations for these resources, which history has shown to be a contributor to war, famine, and political instability. So, how do we get this to look like this? Presently, we have the technology to be 100% renewable reliant. The truth is, our infrastructure is built around our fossil fuel dependency. If we could convert our infrastructure to what's known as a supergrid, we would be able to rely on clean, renewable energy. So, what's it going to be? Will our children live in a world full of pollution, or should they continue the path of evolution?
So welcome back. This class is a continuation of a previous first introduction to basics of electricity. If you want to learn a little more about it, we actually have a complimentary recording on YouTube, and you can always look at the link that we provide. So how do we harness the energy, the solar energy? There are a couple of different ways to do it. Solar panels is the most popular and recognized ways to do it. This cool animation shows you the principles behind the solar panel, where the two different materials, matters, interact using UV rays. And as a result of that, they release energy, electricity. And this diagram here shows us how we take the sun and sun's energy via solar panel, and then we convert it using different components into a point where we have energy that we can actually use. So there are two types of solar systems that we can use. The first one is called a grid-tied system. It captures the energy and we use it either directly or we send it into the grid or the electric lines that you see outside your streets. And of course, in the big cities or in some places, they're buried in the ground. But the bottom line is, we don't necessarily store this energy locally. We either use it or we pass it on. The second type is called the off-grid system, and that's the one we're going to explore a little more today. So in the off-grid system, the captured energy is stored, usually in batteries, and we use it when we need it. Let's take a look at some off-grid solar system components. The first one is solar panel. It captures the energy and it outputs DC voltage. So we talked about different types of voltages in our previous class as a kind of a quick refresher. In a direct current voltage or DC voltage, the electricity usually runs, the current runs in one direction all the time. A very common type is your battery, the little battery that powers up your flashlight, or a battery that starts up your car. You always have a plus and minus, and the electricity always flows one way. Another component, a very important component of the system, is the charge controller. So what it does is it receives the energy from the solar panel, it converts it to the desired voltage, because every battery is different. Some batteries are 6 volts, some are 12, some solar panels are 12 volts, some solar panels are 18 volts. It's important that the batteries receive the appropriate voltage, or otherwise they'll overcharge, overheat, or in some cases even explode. So that's the purpose of the charge controller. It always conditions the electricity to make sure that the batteries receive proper amount of energy, proper types of electricity, and never overcharge. Battery. So the battery is a very simple component, but is also one of the most complex one at the same time. So the battery stores captured energy. There are different types of batteries. We're not going to get in depth about what kind of battery types are there, but they generally vary from A, the cost. Some of the batteries are less expensive, some are more expensive, and B, how efficient they are at storing the electricity. So some batteries only allow you to use 40% of its rated capacity. Others allow you to use up to 80% of its rated capacity. Some weigh 100 pounds, others weigh 20 pounds. So obviously the more capacity you're allowed to use and the lighter the batteries are, the more expensive and the more advanced they are. And then lastly, if you're going to use AC appliances, and those are the appliances that use your commonly found household voltage of 110 volts in the US, you're going to need the inverter. What it does is it converts a direct current that's usually around 12 volts stored in the battery into a 110 volt AC voltage that we use for things like TVs and maybe even microwaves or chargers. So these are the common components of the off-grid solar system. The next step in designing really your overall solar off-grid system is estimating its size. Okay, so the first thing is we want to understand the usage goal. How are we going to use it and how long? So for example, will this be something that will power up your house and you live in it? Or is this something like in the case of our mobile pop-up camper for Antinanka Earth Art School, we use it occasionally when we go camping or we host an event somewhere off-grid. We're talking about a 2-3 day, maybe a week, with driving in between. So understanding how you're going to use the system is very, very important. The next step is estimate the power that's needed. And this is where you need to get a little technical, but not too much. So what does that mean? That means that you need to know in advance what you're going to use, how long you're going to use it, and do you really need it, or is it a nice to have? So for example, do you need light at night when you're camping? Yes. Do you need to charge your phones? In some cases, yes. In some cases, no. But for the security purposes, I think we want to say yes. Do you need to watch TV? That's a different story. Most people will probably say, no, we do not need that. So understanding what it is exactly you're going to be using and how long you're going to be using it, it's very important. Okay? And usually when we talk about the time period, we talk about the time period between recharging. So remember, solar systems can only charge during daytime. And obviously when it's a really, really cloudy day or a rainy day, the system is not going to be working very efficient. So you need to plan in advance. If you're in an area where it only rains once a day, once every couple of days, that's one thing. If you're in the area where it rains 3-4 days in a row, you may want to change your design based on that. Step 3 is identifying the components that are needed based on the estimate. So do you need a lot of solar panels? Do you need a little solar panels? Do you need a very powerful controller? Do you need a very basic controller? And identifying the components is an important step, but can't really complete it until you do the first two. And then the last step is design the system. So let's take a look at every step in a little more detail. So understanding usage goals. We talked about this, home or mobile, short term, long term, 1 day, 2 days, 1 year, 2 years. Primary, auxiliary, or backup. Now, something that we haven't talked about yet. Primary means that this will be the main source of power in your system, your off-grid, your home, your cabin, your boat, your car, something. Auxiliary means it's going to be a secondary or additional. So you may have one source and you're looking to really build a second source in case the first one fails. So for example, if you have a power block out and you want to be able to charge up your phone to stay in touch, auxiliary is a really way to go. But at the same time, backups is another option. So if this is in case really you want to, in case your primary and your auxiliary systems fail, you want to have a backup. It may be a small little system, for example, literally a tiny panel and a controller that has a USB plug for you to charge your phone. Emergency case scenario only. And important other considerations are budget. How much money can you spend on this? Your timelines. Do you have a week to prepare for it? Do you have a month to prepare for it? And if you live in the US, you probably have a good access to online shopping, and you can order a lot of stuff online at a very good price. If you live in the middle of the Amazon, you're not going to be able to really do much on a short notice, so you want to plan way ahead. Step 2. So this is where we go into the details of estimating the needed energy. So first and foremost, list everything that you want to use while you're off-grid. So we have a little table on the bottom. It's a very, very simple one, but you can copy it and you can expand it into many, many rows depending on what you really have. In our case, we're going to have a lamp, which is a really light that shines at night to help us see, and the iPhone charger. Everybody needs their communication device. So those are the two items we've listed here. Next, we have each device consumption rate, and that's the next column there. It's very important, and usually it's listed right on the device. And if you go to the first class, we talk a lot more about how to identify and how to understand it, and we fill in the information into the rating column. So we know what each device consumes as far as electricity. The next step is estimating the length of use, and we can see the running usage time. So a lamp may be used for 10 hours. So from the time it gets dark until the time you go to sleep, or maybe keeping the light on during night. That's all important to know. An iPhone charger, you may only need it for 3 hours, figuring it's going to take you about an hour and a half to charge the phone. Then you want to do it twice. So you want to have that kind of capability. Once you have those 3 items filled out, you can total up everything you need. And in our case, the total on the right-hand side, and it's measured in amp hours, is 3.5 amp hours. I'll take a quick step back and just tell you how we calculated that. So we figure out, based on rating and the running time, the total wattage, total number of watts we need for each of our devices, and we convert that into amp hours. Okay. And then we total everything up, and in our example, we have 3.5 amp hours that we need each day. Now let's talk about the system components. Okay, it's very helpful if you work backwards. Once you know what kind of devices you have and what are your total needs in amp hours. Do we need an inverter? Well, in our case, we have a device that uses your AC voltage. Let's assume for a second that we now invested into the 12-volt cigarette lighter adapter for your iPhone charger. So we just have the one that came with the phone. So we're going to use that. So inverter is needed. And when you're trying to figure out what kind of inverter you need, you usually want to take the rated power of rating of each device and multiply it times about 150%. So 1.5 times that capacity. Then we need to figure out our battery size. So we know how many amp hours we need, and batteries are usually rated in amp hours. So that's a little straightforward. All we need to know is what's the efficiency rate of our battery, and then we multiply times, number of days we want to have in reserve. So we can do 1 or 2 or 3 or even 7 days if we'd like, but obviously that will increase the battery size and cost. One word of advice: the efficiency rate is usually not listed on the battery, and it could be guessed by the type of battery you're getting. Then we're going to figure out how many sunny hours we have in our region, and based on that we'll determine what size solar panel we need. So the solar panel is measured in watts, and we can figure that out based on our consumption needs. And lastly, we're going to select the charge controller that will go well with our solar panel. Now let's design the system. So remember our example, we had 1 lamp and 1 iPhone charger. Let's build a system to support that. We need a 50-watt inverter. So we have a 5-watt iPhone charger times 1.5, 7.5 watt. They don't really make an inverter that small. The smallest one is 50 watts, so that's what we're going to go with. We selected that we need a 12 amp hour AGM battery. Okay, the AGM is the type of battery, and that states that the battery is going to be 60% efficient. So 3.5 amp hours for 2 days. We take 3.5 amp hours divided by battery efficiency and multiply times 2 days, and we end up with, I believe, 11 point something, and we round it up to 12 amp hours. So if the battery you see is larger, it's okay. If it's smaller, then of course you eat into your reserve, or you may need to trim down your usage requirements. Solar panel. So we need 42 watts of power, and the formula on the bottom there tells you that we took the amp hours that we totaled up, multiplied it by the voltage of our battery, that's 12 volts, and we get 42 watts. So we figure if we have a 10-watt solar panel and we use it 5 hours per day, that's what we use in the northeast of the US. That's kind of general statistics. Then that's what the system should do. Okay. Next up is the charge controller. So 10-watt solar panel, we need the smallest charge controller out there, and the smallest one there is 10 amp, and that's going to be plenty. And again, on the back of the solar panel, it will usually tell you how many amps it outputs, and you just need to get the charge controller that matches or exceeds that number. So now that we kind of covered the basics, let's just take a quick look at some of the samples of the installed systems. Now, these are the systems that we have done. The first one on the left here, with lots of kids singing Christmas carols, is our little library house with a built-in phone charging station. And you can see that's a 10-watt solar panel. The controller is placed inside that library structure. And we have USB outputs where you can plug in your devices. The system on the right is a little more advanced. It's a 150 watts, so 15 times more powerful charging capacity than the little library house that's on top of the boat. And the one that's on the left, in the lower left corner, is even more powerful. That's a 200-watt system. That's soon going to be expanded to 300 watts. That's another system for another boat. That's a much larger boat with a totally different use pattern, and therefore the system calls for a lot more power. You can also see that in the first two examples, the solar panels were rigid. They're kind of metal-looking edges, glass-looking structure. And in the third case, we're using what's called the semi-flexible panels. They're very, very thin, and they can be literally glued to any surface you want. All right, so do you guys want to see a solar off-grid control system in action? And if you give us a second, we'll go ahead and we'll switch it over and we'll demonstrate how one works.
Okay, so what we're going to do now is we're going to give you a quick demonstration of our off-grid solar system. Now, this particular one we've set up so we can do just what we're doing now, give you a quick demonstration of various events. So let's take a look at some of the components here. So right here, what you see is a solar panel. Now, this particular setup allows you to lift it up to capture the sun a little more efficiently. We have a battery right here. And we have a charge controller, that little device with an LCD. And that device tells us whether the solar panel is actually working and gives us a little information about the battery, how much power do we have in reserve. And it also has USB ports that you can plug your devices into. Now, also we have lots of lights, and I'm going to go through that. You know, we have different lights that you turn on for demonstration purposes. We also have a pump. Now, this is to show you that you can actually pump water, have water on demand. When we turn it on, the water is pumped from a container through the faucet right here to wash hands, or to, if it's drinking water, you can actually drink from it. And we also have a couple of devices here. We have USB, 4 USB adapter, and we have an inverter. This little tiny device here is actually a 100-watt inverter that you can use to plug in your regular household devices. So that's your system right here. Now, of course, these systems could be made much larger so that they fit on top of the home. And you can also make them mobile, where you can put them on a boat or on a car or on a...
Okay, so now that we've seen how the system works, let's talk about the fun facts about solar energy. So first and very interesting fact is, did you know that Earth gets the same amount of solar energy in 1 hour as we consume in 1 year? That gives you something to think about. In the US, in 2016, a 1 millionth system was installed, a complete off-grid or on-grid solar system. We're not talking about the little ones like the one we just saw, but a big house type of system was installed. A solar panel can generate power even on cloudy days. Obviously not as efficient, but it still can. The UV rays penetrate the clouds. There are also new type of solar panels, which are transparent, are being currently tested and actually used on a very limited basis. So can you imagine, very soon every window will have a solar panel built right into it? Also, there are different type of solar panels. The next generation are being manufactured not from silica or sand, which is what they are now, but instead they're being printed using organic materials. So like a roll of film, you can layer one roll, one layer, then layer another one on top of it, and then layer yet another one, and before you know it, you have yourself a solar panel. You can create miles and miles of it very quickly, and most importantly, very inexpensive. As of last year, the top 10 solar generating countries are China, Japan, Germany, US, Italy, UK, India, France, and Australia. Now, the reason why Italy is highlighted is because Italy generates the largest percentage of its total power using solar. There's 7.5% of entire power generated in Italy comes from solar energy. And for those of you who are watching this as a recording, if you have any questions, you can direct them to Antinanco, ask them in the post in the chat room group, or Antinanco Online University Facebook.